All right. Well, good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. This is one of our final events of the current school year. A lot of classrooms in places across the U.S. are already out for the summer, but for another few more days, we still have some classrooms in the U.S., classrooms in Canada, the U.K., and a few other places before the summer break starts. We'll be taking our own summer break here for 2 months. While we get ready for another crazy school year starting in September. But before we go, we have a couple more virtual field trips. We'll be heading out into the field a few more times. So if you head to exploringbytheseat.com, you can see the events that we do have coming up. You can join in with your classrooms live or catch those recordings later. So let's get into today's event. What are we going to get up to? So you may remember a few weeks ago, we connected with the Around the Americas expedition, a 14-month voyage that just launched in May. They're circumnavigating North and South America aboard the 48-foot sailboat One Ocean. Their mission is focusing on scientific research, education, and community outreach to raise awareness about our ocean's health. So this journey is in the footsteps of another one back in 2009, 2010, that will kind of compare the changes in our ocean over the past 15 years. So when we caught up with the team last, they were in British Columbia. They were showing us some really, really cool tech they were deploying in the water to observe what was going on in kelp forest. So today we're joining them in a bit of a different ecosystem, a bit of a different environment out in the Gulf of Mexico, but they're still playing with some super cool tech called Swift Buoy. So we're going to learn all about what they're up to, what it's going to do, and what they're going to deploy today. So I'm going to head out into the Gulf of Alaska and bring in the One Ocean crew. Hey everyone, how are we doing today?
Wow, what an introduction. Hi, Joe. Thank you. We're really happy to be here. I'm Jennifer Dalton. I'm the project director for the Around the Americas sailing expedition. And we're actually underway in some pretty big stuff. We're crossing the Gulf of Alaska right now. And I'm here with the whole team. We have Tess Shornack. Hi, Tess. You want to introduce yourself?
Hello, I'm the One Ocean Education Outreach and Social Media Manager. Happy to be here.
And over here we have Mark Schrader. Well, sorry, go ahead, Mark.
I think I'm still Mark Schrader. Hi. Nice to be here. What a way to wrap up the school year.
And Mark is the captain, and he was the one who did the previous journey in 2009-10, and we're back out here with him again to redo the same expedition. And
Mike Beamer, the onboard engineer, currently driving across the Gulf of Alaska. We are about 300 miles due east of Dutch Harbor on Alaska. We left Juneau. We've been out here for a week. You can watch our tracker, and in a few more days, we'll hit our destination there.
So we are here today with some exciting stuff going on with the one of our partners is the University of Washington's Applied Physics Lab, and we are collecting some data for them. We have a couple of different methods of doing this, and we'll get to your buoy in just one second, Captain Mark. I know how excited you are, but right over here, follow me. I'm having troubles walking because it's so bouncy out here. But online on our tracker, on our online website, you'll be able to find this tracker. We have some information always being downloaded by the Applied Physics Lab, and we're always tracking water temperature and looking at
Skin temperature,
and
the top of the ocean,
yeah,
a whole bunch of other functions.
So that's constantly going. And then here we are. This is our parent wind. We've got some good winds happening right now, 14 knots and some big seas. But we'll go back to Captain Mark Schrader because he has something fun to share with you.
Well, this is our first buoy drop, and there's somebody else that's going to come on the program here to talk to you all about what this actually does. But we're putting this in the ocean, and it's making measurements, and you can track it on the tracker and see what's actually happening at a specific point in the ocean.
So we have one of our other crew members, Grace Dalton. Are you there, Grace?
Hello, yes I am.
Hi, Grace. Unfortunately, Grace had to go home for a little bit, and she'll be joining us again through the Northwest Passage. We'll be there this summer. But Grace, would you like to do the introductions with our special guest today?
Yes, hi. So I'm very excited to introduce some of the amazing people supporting the Around the Americas Buoy Drop program, which brings together ocean science and sailing. So first we have Jacob Davis, a researcher at the University of Washington's Applied Physics Lab. Jacob works with the Swift buoys. And also a big thank you as well to Dr. Jim Thompson, a senior principal oceanographer and professor at UW, for his guidance and support for this research. We're also incredibly grateful to our sponsors, Sailors for the Sea. They're a huge leading voice in ocean conservation. Joining us today are Shelley Brown, Director, and Stephanie Ruff, Communications Manager. Thank you both for making this program possible. So now I'll hand it over to Jacob to describe what the Swift buoys are and what they do.
Hi, awesome. Thanks for the introduction. So my name is Jake, or Jacob Davis. I'm a researcher here at the Applied Physics Lab at the University of Washington in Seattle, Washington. I actually just recently finished my PhD. And a big part of my PhD was working with these buoys called micro swifts, which you just saw the captain's hands and also right here. So I'm here in the lab where we make the micro swifts. You can see some of their bigger siblings in the back here. These are the big swifts, or swifts. And so what these do is they primarily measure waves. So these will float with the ocean surface. They have these little buoyancy members right here that will kind of keep it upright in the water. And so they're bouncing around. They measure the waves from their elevation. They have this instrument down here, which is a CT, or conductivity temperature cell. This is how we measure temperature and salinity. And they transmit all this data home through satellite so that we can then receive it on our end and then track it using the dashboards that we'll see today. Should I share my slide now, or should I wait till after?
Yeah, why don't we dive into the slides and take a little deeper dive into the Swift buoys?
Sounds great. All right. So here we go. Yeah, so this is basically what is covered. So here on the left, I am showing just a quick schematic of the guts, the sort of circuit board inside of it, where we have this motion sensors, a GPS to track the buoy. Here, this iridium modem in the center is how we send the data to and from satellites. And then the bottom is usually some type of controller. So in this case, the earlier versions had a Raspberry Pi, or the later ones have different computers that control everything going on. So the first prototypes, it's pretty fun. These were actually in an Nalgene water bottle. I actually have one right here, so you might be familiar with that. And so we basically took all these internal electronics and put them inside the water bottle so they could very easily be deployed. And they have since evolved into this V2 that you're going to see today, which have just a lot more batteries and a bit more sophisticated electronics. And here on the right is one floating at the surface of the ocean, measuring the waves, as well as the temperature and the salinity of the ocean surface. So where have these been deployed? Well, we just created these a couple years ago, but already we've got them all over the world. So here on the upper left, you can see we deployed them a few months ago in Ukqiavik, Alaska. Here's actually a picture of where we deployed them on the ice. They also can be deployed in sea ice and in the water. In the top here, we've deployed them in just down the road from Ukqiavik in Prudhoe Bay, Alaska. Here's an image of us deploying them from a helicopter over sea ice. Going clockwise here in the upper right, we've also deployed them in Portugal and Nazaré, which is very famous for having world famous big ocean surfing waves. On the bottom right, we've also deployed them at the beach or in the near shore in the Outer Banks, North Carolina. So we took many of those early water bottle versions and deployed them along the beach to measure waves and breaking waves and understand how that affects coastal erosion. And then the bottom left, this was actually part of my PhD. That's me deploying one of the microswifts out of an airplane so they can then measure waves inside of hurricanes. So they can deploy a number of waves. They can deploy by ships, as we'll see today. They're really small and easy to carry, which is awesome for deployability. We've also deployed them from surfboards. So here's an example in the Outer Banks. In the upper right, here's that image of the helicopter I showed. And we also have deployed them from drones, which I'm showing in the bottom right. So the drone will attach them to the bottom. It'll fly up, go over the ocean, drop them, and then they'll measure. We've also deployed them from a number of airplanes. So on the left, I'm showing an airplane called a Twin Otter, which is flown by NOAA. So that's the airplane in the upper left. And these specialized science aircraft actually have these tubes in them, which I'm showing in the upper, sort of the middle right panel up here, where I'm about to put one of the microswifts, or I have just put the microswifts through this tube. And at the bottom, what you're looking at is a video of the underbelly of one of these airplanes. And that tube you see in the center, if you watch closely, you'll see one of the microswifts sort of rigged up for air deploy with the parachute. You can see it be deployed out of the tube and then make a safe descent into the ocean below. And then we've also deployed them for much bigger planes. So here on the right, this is a P3, which is primarily these days used for science. And so these planes also have those same kinds of tubes, as you can see in the bottom here. So we can deploy microswifts in much rougher environments. So for example, in hurricanes. So we do this often to to measure waves inside of hurricanes and other conditions that we can't get to safely otherwise. And so that's all I have. And I also have this dashboard that I can show. Do you want me to share this now, or should we save this for later?
I think we're going to save it.
Perfect. All right. Well, that's all I have. And I'm happy to take questions.
Thank you so much, Jacob. That's so fascinating. And right now, we'd like to go back to Grace if we could.
Hi, yes, thank you, Jacob. That was an awesome introduction. We would also like to introduce Sailors for the Sea. I know they've prepared a little thing to talk about as well.
Hi, thanks so much for having me. Sailors for the Sea is so excited to be supporting the efforts of One Ocean. We're an ocean conservation organization that works with the sailing and boating community on how they can protect our oceans. And one of the ways that we do this is educating youth. So we have a program called KELP, which stands for Kids Environmental Lesson Plans, where kids, where we have activities, over 50 free downloadable activities on our website for kids to learn about where, you know, for example, the One Ocean is going, like exploring those different types of ecosystems. So all of our activities are free, downloadable. They use very simple materials to carry out. They cover a wide variety of topics, from plastic pollution to overfishing to just ocean health knowledge. And some of them, you're even making your own scientific equipment to measure what's going on in the water today. So again, we're really excited to support One Ocean and the buoy drop, and look forward to seeing how it goes today. Thanks so much for having me on board.
All right. Hello, everybody. We are back with the One Ocean crew, and I think it's time for buoy drop. They're getting it untied right now. We have a little system set up.
So we had to activate it 4 hours early and make sure it was working and connected to the satellites and everything. Keeping it safe. Captain Mark is going to do the honor.
Yeah. And this is the first of 10 buoy drops that we're going to be doing all around North and South America. And you can find the trackers on our website under research. But we're going to go ahead and
We give this to you. Which you get set. There you go. Let me come out there.
all right, Mark's got the buoy right here. And we're just going to go ahead and deploy it.
Gulf of Alaska. Warm, sunny day in the Gulf of Alaska. 44 degrees. Here we go.
Here we go. And it's been dropped.
All right, very cool.
Great. Looking good. Successful buoy drop.
First
All right.
deployment of how many are you anticipating?
We are anticipating 10, and it could possibly be more than that, but we're going to be doing 10 all the way around North and South America, spread out pretty evenly, so we can get data from each point.
You'll be able to find out our information when we do the drops. You can continue to watch our social media sites and websites, and we'll continue to advertise and talk with Joe, and hopefully get lots of schools following these data, because schools can follow the data now for up to 3 weeks, I believe. Right, Jacob?
Let's get Jacob back in here. Here he comes.
Yep, that is right.
Thank you. How cool. This is really neat. Thanks so much, Jacob. Jacob's now going to talk to you about what we're going to be seeing out there.
So Jacob, I think you're able to, if you go to that link, can we actually see data coming in from the freshly deployed buoy?
It might take, they have a sampling window, so it might take some time to collect the data. We should definitely see it within the hour.
Okay.
But we can see, the buoy has been on the ship and powered on, so we might see something. We might see the waves sort of measured from the ship. But we can still take a look, and I can explain the plot so people can.
Yeah, let's do that. If you want to share your screen, I'll cue it up here, nice front and center.
All right.
So while you're doing that, Jacob, there's a question from a group in Nova Scotia, and they're curious if you ever collect the buoys after they've been deployed.
It depends largely on the deployment. So often, for example, in a hurricane deployment, we don't necessarily always collect them, which is, unfortunate. Occasionally they wash up. People will call us. They have our information on them. But if we deploy them at the beach or from a ship, we very often collect them and get them back so we can use them again. That's a great question.
All right. Okay, I see it loading. Let's see if we've got any info coming in.
Yep. Can you see that?
Yep.
Great. So, all right. So we can definitely see their position. Sounds right about where they said they were, I believe. So that is position. And what this is showing here, or let me start from the top. Sorry about that. Okay, so this is going to be the first panel you'll see when you sign on to this dashboard is what we call a time series, where we're looking at some variable measured over time. So in this case, on the vertical or y-axis here, we have significant wave height, which is a statistical measure of the waves. It's sort of maybe on average or a little bit higher what you'd expect the wave height to be. And this is measured in meters here. And then here on the x-axis, this is time. This is in UTC time. So this is, just keep that in mind. It's not necessarily local. And then here you can see the data as it's coming in. It might have been, so the microscope was turned on. It wasn't in the water, but it's still tracking its motion. So it's very likely it was still able to get some estimate of the waves based on this chart. So here we're seeing that we first turned the microscope on. It had a significant wave height of about 0.86 or 0.9 meters, which is about maybe 3 feet. And then it's been sort of steady. And as the buoy drifts around, you can watch this chart here and watch how the significant wave height changes with time based on where the buoy drifts. Further down, the next chart you'll see is here. This is basically just a map where we have latitude and longitude. And so here, this is showing the position. And so I mentioned the buoys report every hour. So here you can see these measurements. There's a timestamp in here just below the latitude and longitude. And so here is one timestamp where we can see the temperature. This is in Celsius. And then the next timestamp, almost an hour later, we will see another point with temperature. And there's just a point down here, which is bright, so you can't quite see it that well. But here, this is where the buoy is making yet another temperature measurement. So we can track the position, how the temperature is changing over time. This is particularly interesting, so we can track the temperature on the ocean surface as the buoy drifts around. This is really interesting when we put the buoys in sea ice, where you have very different pockets of warm and cold water. And then this next panel here is a similar chart where we have a map of latitude and longitude, but this time we're measuring salinity, so basically how salty the water is. And these are in units of practical salinity units. And so the typical ocean is usually around 32. So once we get the first ocean measurement, right now it's 0, right? Because it's been on the boat and it's been in the air, so it hasn't been measuring any salinity. But once we get the first measurement back from the ocean, we'll see it should be somewhere close to around 30 or 32. And then finally, here is a map of wave height versus position. And so this is the same type of map, but here now instead we're looking at how the significant wave height or the wave height changes as the buoy drifts around. And this last one is a little bit more complicated, but it's really pretty to look at. This is basically just showing how the amplitude or energy of the waves at each different wavelength is varying over time. So we don't see quite much right now, but once the buoy's been drifting around for a few days or even a few hours, we'll see a much clearer picture of what's going on here. So that is the dashboard. You can come check this at any time. And also, if you're curious, you can play around with these tabs. Actually, I should have mentioned that you start off when you open the page, it'll likely be on this first Arctic air deployment, which is just another project we have. So you can go and track this data. This is a buoy that is up in the Bering Sea. And so you can change the project here. If you want, you can look back on historical projects. So for example, here is one from a hurricane. So you'll see very big waves here, right? In this case, we see significant wave height of 13.6 meters, which is well over 30 feet. And you can also change the buoys that you're looking at. So for example, here on the Around the Americas, you can either look at buoy 167 or 168 or all the buoys that have been deployed. So as these keep getting deployed, we can see all the data here. And so that's just an overview of the dashboard, and I'm happy to answer any questions about it.
All right, very cool. Well, we do have some questions starting to come in via the chat. Maybe I'll bring in a little bit of our team hiding out backstage for a few of these questions. And I'm going to start with another question from our crew in Nova Scotia. Do these present any dangers at all to wildlife, or could they be damaged in any way while they're drifting?
Ooh, those are two great questions again. They're relatively small, so we hope they don't present too much of a danger to wildlife. And the second question is can they be damaged? Certainly, yes. They've been struck by ships. Sometimes they break on impact if you deploy them from too high up in the air. They're relatively small, and they're robust, but they are they're made of this clear plastic material, so they can be cracked. And particularly when they wash up on the beach and get hit by breaking waves. So great questions.
All right. What about, this one's from Washington State.
Yep.
Is there anything that could prevent the buoys from returning or washing back up on shore?
Sure, if they get caught in currents that take them, further offshore, the Gulf of Mexico is a great example where there's there's the Gulf Stream that comes out of there. So very often our buoys that get deployed for hurricanes will get dragged up in that Gulf Stream and into the North Atlantic, and similar situation with currents here in the Pacific or even up in Alaska.
Okay. So this is from Bainbridge Island, and they're curious about how do you decide, like today, for instance, where to drop the buoy?
Well, I can help with some of that too. We decided along our path to try to hit some areas where it's just wide open ocean so that the buoy won't get caught up back on land right away, and that we know we'd have a few weeks of good floating time for students to watch this data and get engaged with what's going on here. So we have these 10 buoys, and like I said, we will deploy them as we go around North and South America. And obviously, Joe, you're out for the summer, so we'll be re-engaging again with you in September as we're coming out of the Northwest Passage. We'll be doing another big drop out there, and we'll try to do that live as well.
All right, very cool. What about, based on where it's just been dropped, do we have any idea where we're expecting it to potentially wash up?
Well, actually, I think Captain Mark Schrader can maybe talk a little bit about this. We have had out the last couple of days, we have been doing some learning ourselves and learning about the pilot chart of the North Pacific Ocean. And on this chart here, it actually tells you prevailing currents and storms and different things. So we've been watching the current in this area.
So we're approximately here out at the end of the Aleutian chain, and the current from here goes around the bottom of the earth, and this was compiled by dozens and dozens and dozens of years and thousands of miles of shipping over the years. So this is a compilation of all of that experience and measurements. So these currents travel basically, some of them go in a circle right in here, and some of them actually come around the Aleutian chain and go north. So it's headed up to the Bering Sea up through here. So we don't know, but it doesn't look like it'll get washed up on land. It seems like it has a good chance of being wandering around in these areas.
It's hard. It's a little hard to read our chart, but that would be up into, the Bering Sea, that area. So good question.
Yeah.
All right. Well, we're going to have to see when we connect in the new school year how accurate that prediction was. We'll see where that buoy is. And then is there any more before the new school year, or is this the only one before, say, next September? The only drop?
Well, yeah, I think we were planning possibly to do one up in the
Up the Chukchi Bering Sea. They're up in the Bering Sea as we go over the top of Alaska and into the Northwest Passage. We'll probably drop one there. Depends on where the ice is. We don't want it to just get stuck in ice, but in this area, possibility. And we should be there in about 3 weeks.
Then the other one will be between Canada and Greenland.
Yeah, and then the next one after that will be on the strait, Davis Strait between Greenland and Canada. Big icebergs up in that area, and they flow into the North Atlantic. So it'll be interesting to put one there.
All right. So Jacob, this might be one for you. We have someone who's interested in, okay, they understand why water temperature can be important, but why do we want to know wave heights or salinity?
Sure. Well, waves, right, are a big driver of coastal change. So that's something we're often trying to study both in the polar regions in Alaska, where there's soft permafrost that can easily be melted by waves once the ice is gone. As part of my PhD and hurricanes, waves are a big component of the total water level, in addition to storm surge, which you might have heard of. So those are two big reasons why we'd measure the waves, in addition to just coastal hazards, right? And ships operating offshore, we'd like a good estimate of the wave height. Salinity, that is more of a maybe more oceanographic question, right? So for example, a big thing we're interested in, we have a project going on in the Arctic where we are trying to measure salinity right at the sea ice edge, because it's a good predictor based on, how fresh the water is, how salty it is. You can tell how recently ice has melted and how that might affect the refreezing of ice. So that's one big reason why we might be interested in salinity. Great questions.
Okay. So, Shelley, I was just taking a look on the website, and summertime's coming. So, students are getting out. Some are going to be going to cottages. Some might be going on other trips to different places. And I noticed one of your initiatives is becoming a green boater. So if students this summer want to think more about being a green boater on any trips they might be going on, how would you advise them to go about that?
Yeah, it's a great question. We actually have some Kelp our kids lesson plans that are around boating as well. It's always being aware of your environment and how you are impacting it. So if you're on a lake and you're going to be traveling to a new lake, be careful of invasive species. You can properly wash your boat, for example. And when you're washing your boat, try to use non-cleaning products. So there's a variety of different things that people can do to prevent impacts on the water, and boaters and kids that are near the water can be a part of the solution there. So it's just being aware of your impact and then figuring out ways to reduce that impact. So our Green Boating Guide is a great resource. It covers 25 different topics on what you can do as a boater to reduce your impact. And then our kids' activities also help kids learn about why they should reduce their impact, and gives them kind of more information about the environment and why we care and love about it so much.
I went on mute. There we go. I've got the website shared down there, sailorsforthesea.org, where you can find that guide. You can find some downloadable resources and other things that you can use as well. So very, very cool. Let's bring some of our team back in here. There we go. And we've got a couple more questions here before we say goodbye after our successful deployment. We have a student wants to know what it's like on the boat today. Is it cold?
Yeah.
Right here,
Here,
44 degrees.
right behind me, I think you can see we have 44 degrees, which we seem to be averaging. So it's been a little chilly. Not quite the summer weather, that we had when we were in Washington State, but it's all worth it. It's a lot of fun. And we've had some really big storms out here. We had a huge day where we actually saw up to 40 knots, and but we've done a lot of sailing across the strait, which has been fantastic. So
It's a big body of water, so about 1,100 miles, and we have 200 to go to get to Dutch Harbor, and then we head directly north. So, yeah, it's pretty interesting. Lots of routines on board. You have to do everything.
and
Cooking and cleaning and sailing and just being here.
Watching out for ships.
yeah. We're excited that kids from Nova Scotia are watching. We'll be your way when we come out of the Northwest Passage. We'll be heading to Nova Scotia. So you can watch our tracker on www.oneislandoneocean.com and watch for us coming your way.
Yeah, last connection, we had a few classrooms, Nova Scotia, as well as I think it was either North or South Carolina. One of the Carolinas said they're hoping to catch up with.
They did, Joe. They reached out, and we've reached out back to them, and we'll be connecting with those schools as we sail on through their regions. So
Perfect.
thank you very much for making those connections, because we're really excited to reach out to any ocean stewards out there who are looking to do great things for the ocean. We love it.
All right, that sounds great. Follow up to the cold question. They're wondering if you have heat on the boat.
Absolutely.
Thanks,
This is an engineering question.
Engineer Mike. Thanks. You can explain
The
what it
heater
is.
has been working flawlessly. We have a hydronic radiant heat. It provides hot water for cooking, cleaning and showers, and it keeps the cabin nice and toasty. So when we go outside, we put on all of our heavy gear to stay warm, and which is all Mustang gear here on the crew. But when we're inside, the boat is nice and cozy. So we're very comfortable underway.
All right, perfect. I've got someone hanging out in Nicaragua today, Caesar, and Caesar would like to know if the buoys have ever sunk before. Maybe they get hit by a boat or something.
Good question.
Yeah, great question. Definitely a possibility. If the hull cracks and they flood with water, they very likely will probably sink. Yeah.
Yeah, and I imagine that's it then. There's no depth information you can get. You lose the satellite connection and they're gone.
Yeah, exactly. Yeah.
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 All right, very cool. Well, before we do say goodbye for today to our team hanging out with us today, what's next? What's the next big milestone? What are you looking forward to?
Ooh, honestly, it's going to be, we're rolling into it here in Unalaska. Dutch Harbor will be provisioning again. We did a huge provision in Juneau, Alaska for some of the Northwest Passage because we'll be up in that region for a couple of months with not many places, I think, to do some shopping for food. So Unalaska here will be kind of a big place for us to get store it up for the next couple of months. So it's a lot of work and organization to think about meals and even stuff that Mike might need for fixing things on board. So that's where our mind has been. And so the next couple of months are really big for us. We're all really excited. So we've been doing some reading in Captain Mark's logs from his past expedition about what we might possibly expect, and also to see what kind of changes have been made, because I'm sure the ice will be different, and we'll be recording all of our findings and talking about them as we go.
All right, sounds great. Grace, when are you going to catch up with the ship next?
Hi, yes. So I'm hoping to fly in the next 3 weeks. I'll be on board through the Northwest Passage, which is a pretty once-in-a-lifetime opportunity. It'll be very cool. Unfortunately, I had to depart, but the 2 months on board I was on, it was incredible. We saw tons of whales, lots of kelp sites. So I'm back home right now. I'm doing some analysis for the data that we did collect, hopefully to catch up in that. So next time we do live classroom, I would love to share some more information about how all of that's going and what we're seeing out there and the trends we're seeing. So I'm pretty excited to get back on the boat, though. I do miss him. I miss the crew, miss the routine. But yeah, it is nice to come home and see family too.
Great. And Shelley, coming up this summer with Sailors for the Sea, are there any big in-person events, any virtual gatherings, anything you're looking forward to?
Yeah, we actually are launching a few new kelp activities this summer. One is all about warming oceans. So that will be coming out the next couple of weeks. And yeah, we've been working closely with camps this summer too. One other thing I want to mention is there's things that you can do going to camps, like reducing single-use plastics. So what are things that you can do when you're packing your lunch when you're going to camp? Ways to be more sustainable so things don't end up in our waterways that we love to see. So yeah, launching some new kelp activities and getting ready for the school year.
Sounds great. And Jacob, I know we've just had a fresh deployment, but is there anywhere else on the horizon for some deployments of some of those cool Swift buoys?
Sure. Well, as we speak, they're being deployed in Willapa Bay here in Washington. I'm watching Microswifts both by hand and by boat and through drone. We will be hopefully continuing to deploy them into hurricanes this summer. And have some projects up in the Arctic. So lots going on with the Microswifts. So stay tuned. Watch the dashboard.
Good stuff. Busy summers for everyone. I'm going to share another banner here for the oneislandocean.com if you want to follow along. Sorry, oneislandoneocean.com if you want to follow along. Check out the map. Check out some of those deployments. See how things are going in the Northwest Passage over the summer. Just because you're out of school doesn't mean you can't keep up with what's going on in the adventures through what should be probably a very exciting passage through the Northwest Passage. That heat on the boat will probably come in handy.
Sure will. Yeah, sure will. We're excited.
All right. Well, a huge shout out to everybody for joining us today. We had a nice spread across the US and Canada. We had some cool classrooms joining us, some students, some people hanging out at home, which was great. I've got some people saying they can't. Well, I think this is our Nova Scotian crew saying they can't wait to see you in the fall. Yeah. Cesar Nicaragua is saying thank you as well. Great to be able to do this one last connection before classes get a little break, a little summertime.
Yeah, we absolutely appreciate it, Joe. It's just a wonderful way to do a big reach out to students, and a big part of our thing here is education and obviously the research that we're doing on board. And you can find all about the research on our website. But we really appreciate, Joe, what you're doing, and thank you very much for the connection and the time, everybody. And thanks for joining us on One Ocean out here in the middle of our one beautiful ocean.
All right. Great to see everyone. Thanks for a really cool deployment. Thanks, Stephanie, backstage. And yeah, thanks for another great event. I hope everyone has a great summer. Thanks, everyone.
Thanks. See you later.
Thank you.